Hello all, welcome to VJD Academy. This is Anil Kumar, Faculty of Digital Electronics. Sir, today I'd like to teach one of the minimization methods, we can say Boolean algebra. Sir, I told you in the previous lecture we have three types of minimization methods, which are Boolean algebra, kernel map, and also we can say that Queen-McCluskey method. Let us try to understand the first minimization method, we can say Boolean algebra. Sir, Boolean algebra, this is one of the minimization technique. This is one of the minimization method. Let us try to understand Boolean algebra. I told you in the previous lecture itself, it can accept up to 2 inputs and then it can produce output up to 2 outputs in the form of either 1 or 0. So the moment when we look at to Boolean algebra, the things which we need to consider, the things which we need to learn is, we have first thing is, what is the theorems? Theorems of Boolean algebra. And then second one is, we can say order of minimization. Order of minimization. And third thing that we need to see, truth tables. Truth tables. And then fourth one is, we can say Venn diagrams. Venn diagrams. And fifth one, we can say that switching circuits. Switching circuits. And then sixth one, dual expressions. Dual expressions. And then seventh one, complements. Complements. And then the final one, eighth one, we can say statements of Boolean algebra. These are the things which we need to learn when we are look at to Boolean algebra. Let us try to understand each and individual subtopic in Boolean algebra, and then we will try to minimize the logical expressions. So let me take here the first concept, theorems. So basically we have 7 types of theorems of Boolean algebra. The first one is theorems. The first theorem of Boolean algebra is, we can say, NOT theorem, NOT gate theorem. And second one is AND gate theorem. And third one is OR gate theorem. And we can say the fourth one is De Morgan's theorem. De Morgan's theorem. And then fifth one is distribution theorem. Distribution theorem. And then sixth one is consensus theorem. Consensus theorem. And then seventh one, we can say the final one is transposition theorem. Transposition theorem. Sir, these are the 7 types of theorems. Let us try to understand each and individual theorem, and then we will see next concept, order of minimization. Sir, let me take here the first theorem called NOT theorem. The first theorem here, NOT theorem. Here, NOT theorem. We know the logical expression or logic circuit of NOT gate is this. Here, this is NOT gate. The moment when we apply input A, it will produce output Y equal to A bar. So now the equations are the syntax, or we can say that the theorem criteria of this NOT theorem is, let us see, here A is the input, we can say output will be y equal to A bar when this A is go through this NOT gate. When we apply, we can say 1, we will get y equal to 0. And then when we apply 0, we will get y equal to 1. These are the things which we need to understand when we go through NOT theorem. Now, so let us see the second theorem. Here we can say AND theorem. Sir, AND theorem, let us try to understand. Let me take AND theorem. Here, AND theorem, sir, we know the logical expression. Here, logic circuit is this one. Here, AND gate A and then B are the inputs. Y equal to A into B is the logical expression, or we can say output, which means we know the logical truth table. Here 0, 0 when inputs, output is 0, and then 0, 1 is input, we can say output is 0. 1, 0 inputs, we can say output is 0. And similarly, when 0 or when 1, 1 inputs, we can say output is 1. This is the truth table of AND gate. Sir, now let us try to understand based upon this truth table what is the AND theorem. Let us try to understand. The moment when we apply both inputs, here we can say the moment when we apply both inputs A and then A to this logical circuit, output we are getting A. And then the moment when we apply A into 1, we can say output is 1. And now the moment when we apply A into A bar, we can say output is 0. And also when we apply A into 0, we can say output is 0. This is the AND theorem. We just need to remember to minimize logical expression further. Now, sir, let me take the third theorem. We have completed NOT theorem and then AND theorem. Let me take the third theorem called OR theorem. Sir, we have seen two types of theorems, which are NOT theorem and then AND theorem. Let us try to take the third theorem called OR theorem. We can say third theorem called OR theorem here. Sir, we know that OR gate symbol is like this. Here A and B are the inputs. Y equal to A plus B is the logical expression. And now let me take the truth table of OR gate. When we apply 0, 0 as inputs, we are getting output as 0. And then when we apply 0, 1 as inputs, output is 1. And when we apply 1, 0 is input, output is 1. And then when we apply 1 and 1 are the inputs, output is 1. This is what truth table of OR gate. And now let us try to understand OR theorem. So here when we add A plus A, the output is A, we can say. And now A plus 1, when we add the output, we can say 1. And also when we add A plus 0, we can say that output is A. And now when we add A plus A bar, we can say that the output is 1. So this is what the theorem of OR gate. We just need to remember these four theorems so that we will try to understand how to minimize. We can use these four theorems or these four statements when we are minimize any logical expression. Sir, now let us try to understand. We have completed OR theorem also, and then let us try to understand the fourth one. We can say that De Morgan's theorem. Sir, here the fourth theorem, De Morgan's theorem. De Morgan's theorem. Let us try to understand what is De Morgan's theorem. The process of converting a standard form SOP to POS, we can say that, or we can also say that the process of converting sum of products form to product of sum form. Sir, let us try to understand. The moment when we get a logical expression A, B, C whole bar, this is a logical expression. When we take this logical expression, if you want to apply a De Morgan's theorem here here we can say DMT, which means De Morgan's theorem. When I apply, automatically the logical expression will become A bar plus B bar plus C. So this is what logical expression or output of De Morgan's theorem, which means what is happening, sir, here A into B into C. Here there is a AND gate between each and every individual element. This AND gate will become OR gate, which means De Morgan's theorem converting AND gate to OR gate, or we can say that SOP to POS, sum of product form to POS, or we can say product of sum form. And now let me take another example. This is what first example, and now the second example we can say that A, B, or we can say A plus B plus C whole bar. And now the moment when I apply De Morgan's theorem, DMT, the output will become here, sir, A bar into B bar into C bar, which means here OR gate will become AND gate, and now here OR gate will become AND gate. Now we can say that De Morgan's theorem, it is a process of converting SOP to POS, sum of products to product of sum, or we can also say that AND gate to OR gate, or we can say OR gate to AND gate. This is what De Morgan's theorem. Sir, now let us try to understand the fifth theorem. We can say distribution theorem. Sir, here the fifth theorem is, we can say distribution theorem. Distribution theorem. Sir, here the moment when we apply distribution theorem, what will happen to any logical, we can say logical expression. Let me consider one logical expression here, y equal to, we can say A plus into A plus A bar B. So this is what a logical expression, and now I would like to apply distribution theorem. We can say DT. Distribution theorem, when I apply, what will happen? Sir, this is a theorem which will convert here y equal to A plus A bar into A plus B. We know that from AND theorem, here A plus A bar equal to, we can say here 1. Now this will become 1, so the output will be 1 into A plus B. We can say that output is A plus B. This is what distribution theorem. And now let me take one more example here. Y equal to here, sir, B plus A into B bar. This will I want to consider. Now what will happen here? Distribution theorem, when I apply, sir, what will happen here? B plus A, and now this will become B plus B bar. Now this B plus B bar will become 1. Now the output is B plus A, or we can say A plus B. So this is what output. Finally we can say A plus B or B plus A. So this is what output, which means distribution theorem which will reduce one extra, we can say that one common variable, so that it will produce one unique solution. And now let us try to understand the next theorem called consensus theorem. One is consensus theorem. Here we are using one new term called redundant term, or we can say unused term, or we can say eliminated term. Let us try to understand how the redundant term will be identified. Sir, the moment when we look at to consensus theorem, what will happen? The logical expression here, we can say y equal to AB plus A bar C plus BC. Let me consider this logical expression. And now, sir, here the unique solution to find this logical expression. So when we are looking at consensus theorem, here the logical expression given is here. Sir, here AB plus A bar C plus BC. Here we just need to look at the complementing term. Here this is what complementing term, and also here the complementing term is a bar, so that which we need to identify the what is its corresponding term. Here a bar c plus here the corresponding term is here. Here this is what AB, and now here the remaining term is BC. Sir, here BC y equal to AB plus a bar c plus BC, which we need. Sir, here there is no a, so that what I am doing is BC a plus a bar. We know that I want to multiply here a plus a bar. We know that here 1. So what will happen, sir? Y equal to AB plus a bar c plus here BC a BC BC multiplied with a, so that ABC, and now here a bar BC. Now this is what expanded term. Now I would like to take here the first term is AB, and then here the third term is ABC. From these 2 points, we can say from these 2 terms I would like to take common of AB, so that here 1 plus C will become common, AB will common, the remaining term is 1 plus C, and then from second and third terms here AC is common, we can say that a bar c common, 1 plus b will be remains. So now here 1 plus c or 1 plus b, according to R theorem, we can say that we have seen R theorem, a plus 1 equal to, we can say 1. Now here y equal to ab into 1 plus a bar c into 1. Now the final output will be y equal to ab plus a bar c. Sir, this is what final expression. And now let us try to compare this final expression with the given expression, so that we will try to understand what is the redundant term. So this is what given expression. Here we have AB, here AB input and then AB output also, and then here a bar c in the logical expression input, and then a bar c is the logical expression output, and now here BC is in input logical expression, and there is no BC in output logical expression. We can say that here the BC is redundant term, or we can say reducing term or useless term. We can say we can remove it, we can reduce it, so that even then if we can implement logic circuit, the circuit will work. So this is how we can say the terms will be, unwanted terms will be reduced, so that the number of logic gates required is reduced, and then logical connection will reduce, so that power consumption will reduce, and then cost of the circuit will reduce, size of the circuit will reduce. This is how the consensus theorem. Now let us try to understand the last theorem. We can say that transposition theorem. Here, sir, the transposition theorem is also very easy to remember and very easy to understand. Let us try to take the 7th theorem, transposition theorem. Here 7th theorem, transposition theorem. Sir, what is transposition theorem and how to understand this transposition theorem? The moment when we look at any logical expression, here y equal to, we can say a plus b, and then here a bar plus c. The moment when we look at to this logical expression, what will happen by using transposition theorem? How to solve this logical expression? Here, sir, here there are 2 elements. Out of here there are 2 combinations, a plus b and then a bar plus c. Out of these 2 combinations, sir, we have one element is common element, which is a, and then here a bar. So we just need to multiply here a with c and then a bar with b. So what will happen, sir? Here y equal to, we can say AC plus a bar b. This is what output of transposition theorem. And now let me take one more example here. Y equal to a bar plus b, and now into here we can say a plus c. Sir, here we have 2 terms. The common term is a bar and then a. So what will happen, sir? We just need to multiply a bar with c, and then here A with B. So now the logical expression will become y equal to A bar C and then A bar C plus A into B. This is what logical expression. From this transposition theorem also we can understand that, sir, here the given logical expression in the form of POS, we can say product of sum. Here this is product and these two are sums. We can say the given logical expression is in the form of POS. And now the output after completion of transposition theorem, which means when we go through this, when we transfer this logical expression through transfer theorem, when we apply transposition theorem to this logical expression, the output will become here SOP. We can say that product of sum. Here these are the two products and this is a sum. We can say this will become SOP. Here POS will become SOP when we apply transposition theorem. Here also A plus B into A plus C. We can say product of sum. Here the given one is product of sum and then output is sum of, we can say sum of two products. We can say this is SOP, which means when we apply transposition theorem to any logical given expression, which means the output will convert from SOP to POS and then POS to SOP. These are the 7 types of theorems, sir, we have seen. Now let us try to understand what is the order of minimization in minimization concept, or we can say that Boolean algebra concept. Thanks for watching. Please do subscribe.